All right, well, good job on quiz or exam one for week one. Overall, it went well, and I can see you are keeping up with the videos, so thank you. We can't lose good momentum. This is week two, so keep on the videos. Again, set aside time within your schedule that you're dedicating to this class, and before you know it, we'll be at week five. I did want to go over a couple of questions that were on the exam because it's going to be important to know this information going forward. And the information that these two questions touched on is setting up free body diagrams or setting up drawings where we identify forces acting on the object. And so I had these two questions. The first one here: when doing a kinetic analysis of cycling, which force do you not include in the equation sum of F equals ma? And this is really important to know because when we start doing drawings and starting to identify forces acting on the object, it's important to know that we're looking only for forces acting on the object versus by the object. Now, sometimes we want to know the force created by the object, in this case by the person. But when we do our kinetic analysis, we only identify forces acting on the object. And so here we've been treating the bike cycle as a system. And so the force created by the cyclist is not what we're going to include in this equation, F equals ma. What we end up doing is we start looking at forces acting on the object. So in this case, if we're even interested in the force that makes the pedal rotate, then we would be looking at the force acting on the pedal, not by the person. So there's an equal and opposite there, but to use this equation, we only put in the forces acting on the object that we're interested in. Gravity is acting on the object, so we put that in our equation. Drag force is acting on the object, so we put that in the equation. And rolling resistance is a force acting on the object, so we put that in the equation. This is, in essence, the same question, but now we're dealing with swimming. When swimming, the hand of the swimmer pushes on the water, F swimmer, and the water pushes back on the hand, drag propulsion. Which of these forces do you put in the equation sum of F equals ma? So again, we're only looking for the forces acting on the object. And so when we're interested in the swimmer moving forward, we're looking only at the force acting on the swimmer, not the force created by the swimmer. And so the answer is drag propulsion force. I know that seems odd, but let me jump down here to this slide. This is the equation. This is Newton's second law, and I've added in the on and the COM here. To use Newton's second law, we need to identify the forces acting on the object, put them in this equation, we add up all those forces, and we get the product of mass of the object times the acceleration of the center of mass of the object. That's Newton's second law. Newton's third law tells us for every force acting on the object, there's an equal and opposite force created by the object, or vice versa. It's usually written the other way: we create a force, there's an equal and opposite force acting on the object, but this is equal and opposite. But to use Newton's second law, we only use the forces acting on the object. So if I go back to these sketches of kinetic analysis, here's a runner. There's a force of gravity pulling on the runner. What Newton's third law says is that there's an equal and opposite force to this. That means the runner is also pulling on the earth. That's equal and opposite. Here's the ground reaction force acting on the runner. What Newton's third law tells us is that there's an equal and opposite force created by the runner pushing on the ground. We only put the forces acting on the object into our equation, sum of forces equals ma. We may want to know the force of the person pushing on the ground, and when we want to know that force, we actually measure this force right here, the reaction force. I'll go to swimming next. The swimmer is pushing on the water pushes on the hand, and that's going to be the propulsion force. You notice I do not have the force of the person pushing on the water. Buoyancy force is pushing up on the water, or on the person's pushing down on the water. Gravity is pulling down on the person's pulling up on the earth. The head is pushing against the water is pushing against the head. We only put the forces acting on the runner, or excuse me, swimmer, in our equation F equals ma. This gets a little bit more complicated, but if you look at every one of these forces, they are all forces acting on the bike rider system, not forces acting by or created by the object. Drag force, the force of air pushing on the bike rider, well, that means the bike rider is pushing on the air particles. That's the equal and opposite, but I do not put that force into the equation F equals ma. All right. So each of these forces has an equal and opposite force that goes along with it, but we do not put that equal and opposite force into the equation. We only put the forces acting on the object into the equation. And that's how we use Newton's second law. And Newton's third law is easy to remember, and I'm sure you all know it, but it's actually hard to understand often how these two laws have to work together. And we're only using the forces acting on the object in Newton's second law. All right, so that's going to be important going forward. You'll see more questions like this on the final exam, and we need to know this as we go through the kinetic analysis of each sport. Okay, thanks everybody.